And the reason we want to determine reference angles sometimes is because we often will get an angle as the reference angle that we already know the trig functions of. So except for whether it's negative or positive, it's going to be the same value. The reference angle will have the same value as the complete angle. Now remember we said that all are positive in quadrant 1. The sine and its reciprocal are positive in quadrant 2. The tangent and its reciprocal in quadrant 3. And the cosine and its reciprocal in quadrant 4. I told you could remember A, simple, trig, chart. That helps us to determine what's positive and what's negative. Right, so let's see how we might use these reference angles to help us evaluate. So most of you by now, I think you got the first quadrant of the unit circle pretty good, hopefully. If you now, at this point, if you can learn that first quadrant of the unit circle, you can figure out any of the others just by knowing what your reference angle is and which quadrant it lies in. So let's think about the cosine of 4 pi over 3. I want to know what's the cosine of 4 pi over 3, but I don't want to have to think that hard and think about the unit circle and where all it is. So what's the reference angle for 4 pi over 3? Pi over 3. We can take 4 pi over 3 minus pi, which is 3 pi over 3. And that gives us pi over 3. But I mentioned to you that if this is in reduced, it's not 8 pi over 6, it's reduced to lowest terms, that we know that the reference angle is pi over 3.
Wait, how? You just take the denominator and the pi?
If it's reduced to lowest terms, yes.
Is it for all of them or just for that number?
For any that pi over 3, pi over 4, pi over 6. All right, so let's think about this. The cosine of 4 pi over 3. What quadrant is 4 pi over 3 in? Quadrant 3. So what does that tell us about the cosine? It's negative. Now we can just think about pi over 3. What's the cosine of pi over 3? A half. So the cosine of 4 pi over 3 is negative 1/2. Remember, Molly, I think you were the only one that liked the fingers. Okay, remember here, this
Wait, what?
we want to use reference angles to find the tangent of a negative 210 degrees. So if we got a negative 210 degrees, what's the first step?
Convert to positive.
We can convert it to a positive angle, find a coterminal angle by doing what? Add 360. And so that gives me the tangent of 150 degrees. What quadrant is this in? 2. So what's the reference angle?
180.
30 degrees. Okay. We are in quadrant 2. So what does that tell us about the tangent? Negative or positive?
Negative.
It's negative, but it's going to be the same as the tangent of 30 degrees. What's the tangent of 30 degrees? Which is the same as pi over 6.
Square root of 3 over 3.
Square root of 3 over 3. 1 over the square root of 3.
Wait, what does the reference angle have to do with this, though?
We didn't have to think about what it was in the second quadrant. I didn't have to remember those angles in the second quadrant. So the reference angle is 30 degrees. So it's the same as the reference angle, except that it is negative. All right, let's look at another one. 5 pi over 3. And I want to find the sine of 5 pi over 3. Okay, all silver teacups. He likes that better than a simple trig chart. What's the reference angle? The reference angle is pi over 3.
Wait, wouldn't it be 2 pi over 3?
Wait, all slaves.
Reference angle is always acute. 2 pi over 3 is not acute.
How do we get pi to 3?
Yeah, how do you get pi to 3?
All right. There's 2 ways we can do it. What quadrant is 5 pi over 3 in?
3. No.
Is it 4?
Quadrant 4. So 2 pi, which is 6 pi over 3, minus 5 pi over 3, is pi over 3. But what did I tell you about these fractional angles? That's reduced to lowest terms. 5 pi over 3 is reduced. Can't reduce it anymore, so the reference angle is pi over 3. All right, so we want the sine of 5 pi over 3, which is the same as the sine of pi over 3, except that it is negative. So what?
So that reference, or that reduced fraction works even when it's not, like it would work if it was like 7 pi over 3?
Your reference angle is still pi over 3,
Okay.
but you would be back in quadrant 1. All right, so what is the sine of pi over 3?
Good question.
Square root of 3 over 2.
Square root of 3 over 2, but this is the sine of 5 pi over 3, so it's a negative square root of 3 over 2.
Just out of curiosity, how did you get that from your hand?
Why? Square root of 3 over 2. Everything's over 2. Everything's over 2.
Oh, what does this mean?
That's
Cosine would be 1/2. Okay, let's think about the tangent of 11 pi over 6. Mm-hmm.
So if you're finding the reference angle and you're in radians,
Theta's in quadrant 2. And the sine of theta is 1/3. I want to use identities to find the cosine of theta and the tangent of theta. So I don't want to use right triangles, I want to use identities. So how can we go about finding the cosine of theta? Using identities.
Sine squared plus cosine squared.
Sine squared plus cosine squared equals 1. Okay, so we've got 1/9 plus cosine squared equals 1. So cosine squared theta equals 8/9. So the cosine of theta, when I take the square root of both sides, I get a positive and a negative. But in this case, is the cosine going to be positive or negative?
Negative.
Why?
Because it's quadrant 2.
Quadrant 2. So negative
8
Negative.
square root of 8 over 3.
square root of 8 over 3, and the square root of 8 is
Uh,
2 square roots of 2. Always reduce it if you can. Okay, now how can I go about finding the tangent? So the tangent of theta equals, you remember that identity?
Tangent squared plus 1
Secant squared,
Yeah.
but that's not going to be extremely helpful.
Isn't this the fraction one?
Fraction one. Tangent theta is
isn't it 1 plus
Sine over cosine?
sine over cosine. If it's y over x,
Oh,
we said sine was y, cosine was x, so the identity is sine over cosine. So in this case, we're going to have sine, which is 1/3, over a negative 2 square roots of 2 over 3. And anytime you have a fraction like this, those denominators are going to cancel each other out when you flip and multiply. So we get a negative 1 over 2 square roots of 2, but we can't leave that square root down there. So we get the square root of 2 over 4, a negative square root of 2 over 4 for the tangent. Okay, the sine of theta is negative 5/13. And we are in quadrant 3. And I want to find the secant and the tangent. So what might we want to find first?
Cosine.
The cosine. Maddie, how can I find the cosine?
Isn't it like cosine, or it's like sine squared plus cosine squared?
Okay, sine squared plus cosine squared equals 1. So the cosine squared equals what's 1 minus 25 over 169?
144. I mean, 144 over 169.
Okay, when we take the square root, are we going to have, what, we're in quadrant 3, so are we going to take the negative root or the positive root? Negative root. And so we get a negative 12/13. Can we find the secant now?
Can't.
Katie, what's the secant?
13/12.
Negative 13/12. Because that's a reciprocal identity. And then the tangent. Remember, that's going to be sine over cosine. So what is our tangent going to be, negative or positive?
Positive.
Positive. And what will it be? 5/12, because we'd have 5/13, negative 5/13 over 12/13, and the 13s cancel.
Wait, wouldn't it be negative or negative 12 or 12/5?
No. Sine over cosine.
Okay.
So those cancel, and that becomes a positive. And in degrees, find the cotangent of 410 degrees. Using your calculator. And when we're dealing with the trig functions, we usually round to 4 decimal places.
89.863.
89 point, William says,
I
what,
got 80.839. Yeah. You might be in rating here.
.8391.
I did a tangent to the -1. I know.
But,
That's the different.
okay, oh, did you
He did tangent. to
do
second half.
tangent 410 to the -1?
No, it's tangent to the -1 in parentheses for 10.
No, that won't work. Obviously, because you got the wrong answer.
Yeah.
Go on.
Which -1 did you do? Okay, that is when you have the value for the tangent and you're looking for the angle. That would be the angle of that would be the angle whose tangent is 410. This is your, that's the one you could use. Did everybody get .8391? Make sure that that's what you get on your calculator.
Yes.
Okay, let's go to radians. Let's go to radians and find the sine of a -7.
656.
Oscar, what'd you get?
What was the question? Oh,
Katie says no. What'd you get, Katie?
-656.
Okay. Decimal?
Yes, 0.652.
Are you in radians?
No.
Then that's fine.
Okay.
What about the secant of pi over 9? We need to be in radians or degrees here? Radians. The secant of pi over 9. Peter?
1.0642.
Do you agree with that? Katie says yeah, Molly says yeah. Okay. Do we need to talk about that one? Everybody get it? Okay, last thing, this is without a calculator. I want to find two solutions without the calculator. There's two angles between 0 and 2 pi that have a sine of 1/2. What are those two angles that have a sine of 1/2?
It's pi over 6.
Pi over 6 and 5 pi over 6. How did you get 5 pi over 6?
It's like 1/2 above the y-axis.
And it needs to be in which quadrant to be positive?
The
Second quadrant.
Wait,
Okay.
how did you get the half above?
It's not a half above, it's just one, it's pi over 6 above
I'm
the,
thinking of
I
like, the
don't-
way I wrote it.
But how did you get, how did you add to powers?
okay, we know our reference angle is going to be pi over 6, right?
Yes,
And we know it has to be quadrant 2, because sine's positive in quadrant 2. So in quadrant 2, we have pi minus pi over 6, because pi over 6 is our reference angle.
oh,
And so that's 6 pi over 6 minus pi over 6, which is 5 pi over 6. Okay, if we're thinking degrees, what's pi over 6 equivalent to? 30 degrees. So what would our second quadrant angle be?
wait,
60.
oh,
It's going to be this time 180 minus 30, 150. Okay, let's see if we can determine where's the sine of theta equal to negative 1/2. Which quadrants will we be in? 3 and 4. So what's our reference angle? Michael, what's the reference angle here? What was it on the first one? 30 degrees. So what is it on the second one? 30 degrees. The only difference is there the sine was positive, here it's negative. And that just tells us we're either in quadrant 3 or quadrant 4. So if the reference angle is 30 degrees, what's the quadrant 3? We're going to have to take 180 and add 30 degrees to get the angle. And so what is it going to be? 210 degrees. If we wanted to express that in radians, what is that in radians? 7 pi plus pi over 6 is 7 pi over 6. What about quadrant 4? How do we find a quadrant 4 angle if we know the reference angle? 360 minus 30. So that's going to be 330 degrees, or what would it be in radian measure? 2 pi minus pi over 6, which would give us 11 pi over 6. It's just thinking of fractions. He knew it was 2 pi minus pi over 6. So not too bad. You just figure out what's the reference angle, and then based on which quadrant it's in, you can easily determine the angle. Max is on page 316 and 317. And it's, I believe, 53 to 61 odd. $69 to $96 every third. And make a little more room here. 97, 98. And 101 to 104. All right, and you will have a quiz on Friday.